All right, this is the Science 7 and 8. We'll talk about a little bit about the pressure, which is Unit 3 in grade 8, for soda can heat and cool experiment. This is the explanation, trying to explain why did this happen. We had a can of soda with no soda in it. We put a little bit of water in the bottom, just a tiny little bit, heated it up, took it into and flipped it inverted and put it into this bowl of cold water upside down, and that can suddenly the sides caved in and it was crushed. Before you watch this video, I want you to try to do the Google form that is the explanation as to why this happened. So try to do the explain part first on your own. If you're following through the Google form, you'll be able to you'll be doing it in the proper order if you follow just through the Google form, because these videos will be in there. I think to explain this best, we need to remember what particle theory is. So this is something in grade 7 we learned in Unit 2. Let's look at this a bit. Particle theory has 4 points. Everything around us, this table, this paper, this pencil, the water in the can, there's all sorts of things, are all made of tiny little particles. There's atoms, there's compounds, different elements. That's the first part of this theory that explains why things work the way they do. Number 2 of particle theory is that everything is always moving. All those tiny little particles are moving around. Some of them are not moving so much, and some are moving quite a bit. And it's based on the amount of kinetic energy. Kinetic means movement, so the movement energy that's in them. Solids will not have as much kinetic energy. Their energy would be lower than a liquid or a gas. Gas would have the most kinetic energy, whereas liquid, it's able to move a little bit, but not as much. Even the solid, these tiny little particles that make up something solid and they're rigid and they're all together, would still also have that little bit of movement because there is still some energy there. The third part is that these particles are attracted to each other in different ways. Sometimes they form chemical bonds, and sometimes they have hydrogen bonds and all these more complicated things to be learned about maybe in later years in chemistry. But they are attracted to each other. In a solid, they're really together, and they're solid, they're rigid. That's why I can knock on the desk and my hand doesn't go through, because it's solid, because those particles that make up the desk, the wood, or in this case it's mostly plastic, hold together. And the last one is that there is space between the particles. In fact, most of what is in there is not actually the particles, but it's the space between them, which is a very interesting concept. Within an atom of an element, most of it is actually just open space, which is kind of interesting that things are still so solid. But it is something that is part of the particle theory, that there's space between the particles that make up a substance. So quickly again, tiny particles always moving, attraction to each other, and there's space between them. Now looking here, I drew solid, liquid, gas. These are the tiny little particles. I drew 21, I think, in each box, that make up some object. And we know about solids is that they're solid, rigid things. So I'm going to write down rigid. And they are not able to move as easily. That's why solids will be kind of a fixed shape. Their shape is fixed. Then you move up into liquid, which has higher energy. So energy's been put into solid. For example, you've got something frozen like ice, and you heat it up. Those little particles are going to be able to move around. That's why water is able to slush down in the bottom of your cup, that sort of thing. You heat it up again, you add some more energy, you make some more energy, that water turns into gas. So if we think about what we just did with our experiment, we had a bunch of water here in the bottom of this can, liquid. We heat it up, and what's the stuff coming out the top? It's water vapor. It's water in the gas form. So that water here is filling up this can. It's pushing the air particles out of this can, and the water vapor is starting to fill this can. There's water particles. There's little tiny particles spread out all throughout this can. They're even coming out the top. That's how we know that it's boiling. And that water, it's slowly, that amount of liquid water is getting less because some of it is turning into this water vapor. So it's got lots of energy. There's lots of energy in this can. There's lots of energy in those particles. What happens is we take it and we put it upside down into this water. The reason I do it upside down is partially because then there's some connection between the water that's cold. Remember, this is cold. This was hot. Okay, and when I say cold, I don't mean it's actually cold. I just mean there's not much heat in it. And this can goes upside down. And suddenly, the heat that's gone from this oven into this can, into this water that's turned it into water vapor, this heat in here that's turned into kinetic energy and caused these water particles to move around, is suddenly going to have its heat need to be redistributed into this cold water. So the heat leaves this water vapor that's in here. The heat leaves it and goes into this cold water very quickly. Because the energy is leaving, those particles are no longer spread out. They're no longer like this. They are getting close together and they turn back into liquid. Most of those turn back into liquid very quickly. It's very sudden. Why? Because the temperature difference between these two things is substantial. Okay, it's the difference between about almost 100 degrees Celsius and almost 0 degrees Celsius, give or take, depending the purity of the water and that sort of thing. But on average, it would be 0 and 100. Those particles, they condense. They go really small. And what happens is it causes the pressure of the can, the pressure in this can, to be lowered. And pressure is a force on an object. And if the pressure lowers in the can, what happens is the pressure on the outside, the atmospheric pressure, the air pressure, is much higher than in the can. And what happens is it pushes in to the sides of this can. It pushes in to equalize the pressure in the can with outside, which is why it's important that we put this in upside down, because then there's the seal of the water on the bottom of the can. That can has no real opening. And so it ends up getting crushed because the air pressure presses in on it. The reason why we found that there was a lot more water in there is because as the pressure lowers, it not only allows for the outside atmospheric pressure to push in, but before that happens, it actually sucks some of this water from this bowl into the can, actually. So as these particles shrink, it actually, because there is that small opening there where you usually drink from, some of this water actually gets sucked in to try to equalize the pressure, but because the temperature is such a drastic change, the heat is going from this can that's hot into the water. It ends up sucking water into there, which is why when you took the can out, there's so much extra water in this can, because it actually sucks some back into it. Some concepts that this shows. One is that heat goes from hot to cold. It went from here, from the can into here. It also teaches a little bit about conduction. Conduction is that heat can transfer through contact. Two things that are in contact, heat transfers between them. The hot stove heated up the can, which heated up the water. And the hot can actually warmed up this cold water a little bit. And as it got rid of that heat, it ended up cooling down. It also teaches about pressure, that pressure tries to equalize, and if a container is not able to withstand it, you're going to be able to crush or expand something which is a grade 8 concept in our Unit 3. Well, I hope this helped make it make more sense. If you have any questions, please, at the bottom of the Google form, I'm going to have a little spot you can put any questions.